Everyone, we're talking about something that sounds a little scary at first. Simplifying radicals by reducing the order. But don't too worry. By the end of this video, you're gonna say, oh, that's it? So, let's jump right in.
So, what does reducing the order even mean? Well, when you have a radical like 6, 8, or 10, the number on the outside, the index, tells you what kind of root it is. Sometimes the index is bigger than it needs to be. The goal is to make that index smaller without changing the value of the expression. And guess what? We can do that by using the greatest common factor, or the GCF.
Here's the secret formula. You have something like square root of n and n index and m exponents share a common factor. You can divide both of them by that number. That's it. That's the whole trick.
With that, the introduction is already done. Thanks to March, we already know the formula that we're going to use. We prepared 3 stages of examples. One is easy, one is medium, and one is hard to give you the challenge for your upcoming exam. So, let's jump right in! First easy example, we have this. The first step is to look at the index, which is number 4, and the exponent is number 2. First, you have to ask yourself, what number can we divide for the both of these numbers? Do you know? Yep, number 2. So divide the index and the exponent by 2. 4 becomes 2, 2 becomes 1. Now we rewrite it, which becomes square root of x. And boom, you just reduce the order of the radical. Easy, fast, and done.
My example, we have the square root of 45y cubed. We will have to factor 45 and y cubed. First, we do 9 times 5, and for y cubed, we have y squared times y. Notice how both have one perfect square? Because that is the correct way of factoring it. Next, we identify the perfect squares. In this case, we have the perfect squares, which are 9 and y squared. After that, we split the square roots. We have 9, 5, y squared, and y. Then we pick the perfect squares. These perfect squares are now to be simplified, 9 being 3 and y squared being y. After that, we write the simplified form, which is 3y square root of 5y. That's it for my example.
Now, after we're done with the easy and medium problems, now we have the hard problems. Let's do the first example, which is square root of 20 plus square root of 45 over 5. First of all, we've already learned in the easy and medium examples that in order to reduce the square root, we have to find 2 numbers that when multiplied equal to the number inside of the radical, which is the radicand. First, let's find the 2 numbers that when multiplied equal to 20. Of course, when we do this, we have to use a perfect square number. The 2 numbers that when multiplied equal to 20 are 4 and 5. But of course, we also have 45. The 2 numbers that when multiplied, and one of them is a perfect square, that equal to 45 is 9 and 5, which when we reduce is equal to 2 square root of 5 and 3 square root of 5. Now, after we have the 2 of those, we of course have to divide by square root of 5. So let's do 2 square root of 5 plus 3 square root of 5 over square root of 5. Now, once they're in the division table, we can cancel each square root of 5, and after, we will get just 2 plus 3, which is equal to 5.
For this next example, to simplify the radical square root of 98 a cubed b raised to 7, we first factor out each part to identify perfect squares, like 98 equal 49 times 2. And then we pull out the perfect squares, like square root of 49 equals 7, and square root of a squared equal a, and b raised to 6 equal 3. Leaving the non-perfect factors inside the radical gives the final simplified form equal a7ab cubed square root of 2ab.
Do square root of 75 minus square root of 12 over square root of 3. Now, to solve this, we already know that we're gonna have to find a perfect square number that when multiplied is equal to 75 and 12. Let's do 75 first. The 75, we can multiply 25 by 3. 25, which is a perfect square number, has a square root of 5. So, square root of 75 will be equal to 5 square root of 3. Now, let's do 12. 12, the two numbers that when multiplied are equal to 12 that have a perfect square number is 4 and 3. The square root of 4, we already know, is 2. So square root of 12 will be equal to 2 square root of 2. Now, let's put them into the division table. Now we have 5 square root of 3 minus 2 square root of 3 over square root of 3. Now that they're in the division table, we already know that we have to cancel out each radicand in the table. So let's get rid of all the square root of 3's. Now we'll have 5 minus 2. Now that we have 5 minus 2, it's really easy. We can just do 5 minus 2, which is equals 3. 3 is our final answer. And that's basically it. Once you know how to look for the GCF, reducing radicals becomes super easy and super fast.
If you want us to make another vlog about how to simplify radicals, even more, how to solve problems using this trick, let us know. Thanks for watching, and don't forget to like and subscribe and keep learning. Bye!